So what I want to talk about tonight are thoughts on engineering velocity and ways to support and grow it. So by way of some quick introductions, my name's David Rouse. I'm the Director of Engineering here at HiMamma. My pronouns are he and him. I've been in the tech sector now for 23 years, first as an IC and then as a leader manager. I live with a formal ADHD diagnosis that has nothing to do with the presentation I'm going to give tonight, but I want to put a big shout out to anybody else out there who's neurodiverse. It's okay to be neurodiverse, bring it forward. Yeah, and I'm really into mountain biking. So that picture there is me in Quebec last year at a downhill park called Bromont. So moving on from me, HiMamma, we're a software as a service product company focused on early childhood education. We make software that help people who run daycares. Administrative requirements, designing and delivering curriculum, recording observations, generating development evidence reports, billing families, and then providing like near real-time feed of pictures and videos of what the kiddos are up to in the classroom, and a sort of report at the end of the day about how your child did, because, well, daycare age children have a hard time telling you how their day was. So that's HiMamma. Our tech stack is largely Ruby on Rails. We also use GraphQL, React, and React Native on our mobile side. So when I started putting thoughts together for this talk, I realized there was a lot of different things I could cover. So to sort of make it manageable, what I want to do is focus on some thoughts about things you can do to maintain higher engineering velocity at the team level. You may call it a squad or a pod where you work, but I want to sort of start at the lower self-contained unit level as opposed to trying to talk about department-wide or org-wide. There are lots of things you can do at those levels to make things better as well. But this is where I kind of want to focus. Also, this talk won't have a lot of focus on things like story points and burn down charts and PR cycle time. So, if you were hoping for stuff about that, maybe go make a margarita and you can watch a little more passively. So, what do we mean when we say engineering velocity? Lots of different definitions of it out there. The one I thought was kind of interesting, I came across a blog post by Omar Ravalini, which I probably just murdered your last name, I apologize. And he describes velocity as saying that the speed is the time it takes to implement a feature. Velocity is that minus the code debt introduced in the process. And that's a pretty good definition, and it's pretty close to the one I work with. My definition of engineering velocity is it represents the amount of good quality work a team can consistently deliver. So when I say good quality, I mean code that's sufficiently performant, secure, extensible, scalable. It can be run in production with confidence, and we can build on it in the future without breaking into tears every time we go back to touch that part of the code base. What do I mean by consistently deliver? I mean, this is the rate at which the team can push work through while accounting for things like vacations, illnesses, that kind of stuff. And if you notice, I don't have any kind of a mathematical formula on the screen here, but there's a reason for that. Largely, how you're going to measure this is going to vary from org to org. And trying to get down to that number actually isn't quite as important as it seems, because if you can do the work in other ways, it sort of takes care of the need to report a number in the first place. So the other thing that I want to be really clear about is, yeah, we're not talking about IC productivity when we talk about engineering velocity. If you have not read Martin Fowler's article on why you cannot measure engineering productivity, go check this article out. It's a really powerful one. So that said, let's get on to some ways. I put together a short list of 3 different ways you can kind of work to improve velocity at your team levels. So the first one is don't do Scrum. And having said that, somewhere there's a certified Scrum professional who just sprayed martini all over their screen. I want to be really clear. I don't have this up here as some sort of like attack on Scrum as a methodology. I just feel from my own experience, there are other methodologies that in the long run wind up working better. Now, there are some times when I would advocate for using Scrum. If you're forming a new team, if the team structure has changed significantly, like you merged 2 smaller teams together, or a bunch of people got moved over to another department, or the other time would be when the mandate changes significantly. And the reason I would say to use Scrum in those cases is, well, number one, it's the most widely understood of all the Agile SDLCs. In fact, it's often used interchangeably with the term Agile, but people who aren't real deep on Agile. It throws off tons of smell indicators about how things are going. There's just metrics all over the place that you can look at. And it's really helpful for facilitating the how are we doing conversations, which are really important in the early stages of team formation. You're probably familiar with that concept of forming, storming, norming, performing. There's articles out there about that. So I think that's a good time to use Scrum. I think basically though, once you're past the storming phase, you should start moving away from it. And but why? Says somebody in the audience. Well, the reason for that, there's a few things. Number one is, in my experience, Scrum winds up putting, I would say, the emphasis on the wrong syllable. We're tending to the wrong things in the engineering process. And in a lot of places where I've worked, I've seen it lead to disempowered engineers. I've seen engineers have to ask permission to fix bugs. I've heard people say, like, no, Linda, your role isn't to participate in the definition conversation. Your role is to tell us how long it's going to take printable 3D QR codes. And you're like, but wait. Yeah, the other thing about with sprints, it kind of creates this artificial stop-start cadence, which I'm not sure is really helpful for if you really want to maximize engineering velocity. And if you're onto modern deployment practices where you can deploy nightly or weekly, that the start-stop of sprint isn't quite so critical. Yeah, so these are some of the reasons I really think there are better approaches than Scrum. That said, I've used Scrum at lots of places. We're actually using it at HiMamma right now on most of our teams. We got like one team that's running Kanban very well. But there's a much bigger reason why I don't think you should do Scrum. And that is that the underlying premise of Agile estimation revolves around relative efforts expressed as a sum of story points. So this thing kind of took 3 weeks to do. This thing looks kind of equally complex. It should also be about 3 weeks. But this is a great video. A lot of this, what I have up here is straight out of this video by a guy named J.B. Rainsberger. He's from PEI. He's a TDD expert. And he talks about the fact that the cost of delivering a feature is a function of two sums, right? One is how complex the answer is to the problem. So, we have to audit a tax code was the example he gave. Right? It's very complex. And then he also refers to what he calls accidental complication. So this is tech debt, problems in how we work, all this sort of thing. And he says, so the cost of delivering your feature is the essential complication plus the accidental complication. And he says, the accidental complication in most systems dominates. So what that does is it renders your estimates very, very, very inaccurate. Where you are is you're in a situation where unless your tech debt is uniformly distributed, or unless your tech debt doesn't exist, your estimates are going to get blown up by what we would call accidental complication. This is why you've got teams who they'll do their best with sprint over sprint over sprint, and like the numbers look okay, but we can all feel it. It's not working right. And that's why trying to measure these kind of things as an indicator of like what's wrong, what do we need to fix, may not get you there. Similarly, measuring things like using tools to measure how long an individual contributor takes to get a PR through. Most experienced engineering managers will sort of figure out who's faster and who's slower at PRs intuitively anyway over a bit of time. And again, looking at cycle time on PRs, that'll probably give you a better map of where your tech debt is as a proxy measure than story points will. But again, it's not really going to do a lot to help you tune the actual velocity on the team. So what I'd recommend doing instead is using Kanban. And what I would suggest doing here is, instead of estimating, forecast. And that is to say, look at the project to be delivered and divide that up into milestones based on functionality, not time boxes. And then the idea is you ruthlessly prioritize the effort to get to the first milestone, and you protect the team while they're working on that. I think this is a really big differentiator for getting the best quality work out faster. I would go so far as to have a rotating engineer on the team be the one responsible for handling any unplanned work that comes in. Team has to own what they put in production, and if you're finding defects of what you just released, don't add it to the backlog, stop and fix it, and then move on from there. One of the other secret weapons in Kanban is the control chart. If you learn how to read one of those really well, it's actually a really powerful tool. There are some things I would definitely keep from Scrum. Periodic retros are really important. The team needs time to work on the team. You should check in on your work in progress like once or twice a week, and definitely run forward planning session on a fixed cadence. These things sort of help defeat the forest for the trees problem that can kind of come up. So leave that as the first point. So moving on to the second point, invest in your tooling. And everybody's going, yeah, come on, we all know this. But make sure your monitoring is looking at the right stuff in production. Your test suites need to reliably pass and fail based on actual defects in the code. Your dev environment setup should be 1 click, 2 clicks kind of thing. It should not take days to get a new engineer onboarded, and it shouldn't take tribal knowledge. And your deployments should be automated. Not that being able to deploy isn't a skill set that an engineer should have, but you want your brain power for solving hard business problems. The deployment can be fully automated, and it should be. And I'm sure everybody's going, well, yeah, come on, we've all got this in our companies. But some of these things might look a little familiar to you. You've got all these things in play, but they're not really giving you what you needed or hoped they would give you. And I think this is really important to zoom in on, because honestly, there is no greater return on investment you're going to get in terms of engineering velocity than getting the tooling kinks out of the way. One of the things I'll often do when I first join a company is go through the day one, I'll start the process of setting up the dev environment on my own machine, and how long that takes me, how many people I have to talk to, how much contradictory direction I'm given. These things are all really good indicators of what I'm likely to find in the code base and in terms of process challenges. So so how do we do this, right? What I would highly recommend is take whatever the largest problem is that's causing the biggest impediment to the largest number of engineers, and do a cell job. Work your way across not just your own team, but this is one where you're going to have to go out to the department level. Get everybody who's impacted bought in that this needs to be fixed. Set up a working group or pull together a committee of the willing, whatever, and come up with how you want to fix the problem. Once you've got that sort of architecture banged out, get the work out to all the teams so that everybody participates, and make this a rallying cry, right? We deserve better, is a good way to combat this. So getting everybody involved gets a higher level of ownership, and these things will pay dividends. The other thing I would suggest is empower engineers to fix unidentified issues in process. So if I'm running a test suite and it fails, and I can go identify that it failed because of a flaky test, no, don't put a story in the backlog. Stop and fix the test. Unless it's going to be some huge refactor, okay, fine, let's be sensible about it. But if you're looking at it and it's oh, it's a date time issue and the time needs to be frozen in the test, fix it. You're not only paying yourself back, but you're paying everybody else on the team back. The other thing that's really important to do when you're doing this is to measure your before and afters, because if you invest a large enough amount of time to this, a well-intentioned stakeholder from outside of the sphere of concern is going to come by and ask, are we wasting time in this area? And having to be saying things like it's really important aren't going to wash. So having metrics to support why we're doing this is really, really important. It also gives something for people to celebrate as they get there. And I think it's one of the really important ways to think about this is, if you spend 20 minutes waiting for a test run and then it fails due to a flaky test, well, you've got to run it again, and that's 40 minutes. That's not 40 minutes of lost time. That's like 80 minutes of lost time. It's the 40 you spent going in the direction of what is this and why won't it work, versus the 40 you should have been putting on forward motion on the business challenge you're trying to solve, right? Or the engineering challenge you're trying to solve. Yeah, so the third thing I would say that is a way that you can increase velocity at your team level is to not have architects. And now a different group of people are spraying margaritas on their screen. Again, this is not a rally or a rail against people who are in the role of architects. This notion, I actually sort of fleshed this out with a friend of mine who is an architect and was an architect when we came up with this idea. And the big thought here is that good architecture is critical. Architect as a role, not so much. And so why not have that? Well, the reasons I've got listed here on the screen. You wind up with different classes of engineers. Depending on your org, people can be bucketed into thinkers versus doers, which is disempowering. The architect feels like they have an impossible task of controlling what they feel like are a horde of barbarians. The engineers feel like we already have enough obstacles, and now we have the wizard coming down from the ivory tower to tell us we can't use that variable name or whatever. And what it really winds up with is a high level of frustration and friction for everybody. And that is a mental tax that you won't be able to erase. So if we're not going to have people in the role of architect, then like, how do we ensure that we have good architecture? I think there's a two-prong, it's actually a 2.5 prong approach, but the main two prongs of this are, one is an approach that I would describe as team-wide planning. And the second is to leverage the concept of staff engineers. So by team-wide planning, what we do this at HiMamma, and I've done it at other companies as well, where you have, instead of having a team lead or an architect who works with product and design to do the planning and the solution architecture, you have a rotating role of somebody called a tech lead. And what you'll do is, for the more challenging projects, you'll have your senior engineers take that on. But for smaller or more straightforward projects, it's a really great idea to get your intermediate engineers involved as leaders, working with product and design. This pays back a lot of benefits. One, by the time they get to senior, they already understand the role better, and they'll flourish and be more successful earlier into their tenure as senior engineers. It's also good because it helps everybody understand exactly how easy it is to plan a project. So I think that's the role, the way I would approach it. The other thing we do is what we call team-wide planning. So the tech lead will work with product and design to come up with the overall solution architecture. That's then brought to the engineering team, and then the various pieces of that are divvied up amongst others on the team, and people go off and plan those individual pieces. So what you're going to get out of this is you're going to get a lot stronger engagement and ownership from everybody on the team because they're involved in actively planning the project. You get rid of your bus factor of one. Like I've worked a lot of places where we had team leads, and the team lead was expected to do all of the definition work with product and design. They were expected to participate in forward-looking tech evolution. They were expected to write all the stories, answer all the questions. Oh yeah, and since they're the senior person on the team, they should also crank the most code. Yeah, they wind up being grumpy and a little bit burned out. So this helps get away from all of that and spread that feeling of ownership and autonomy more strongly across the team. Now, one of the things that architects typically do that is really important, though, is defining and controlling standards. If you don't have standards, you have chaos in your code base, and you have a bunch of spaghetti and competing implementations of the same things. So what I would recommend instead is creating or enhancing the capacity of what are called staff engineers. They're part of the engineering leadership team. They'll work with and in front of the team, sometimes even embedding and coding alongside them. Otherwise, they're involved in setting standards with the rest of engineering leadership. And occasionally they're involved in compliance enforcement to say, hey, no, I'm sorry, you can't add that library. It's got too many open issues and it's not supported. Let's look at some other alternatives together. Yeah, and Rose Weekly, I probably just destroyed your name, Rose. I apologize. She works at Shopify as a staff engineer, and she wrote a really great post on what a staff engineer should be. This is pretty much like right down the line with my thinking on this, and I would highly recommend everybody check that out. So that's the second part. The third part is the 2.5 part is to automate your compliance as much as possible. And this kind of ties back to your tooling. Um, you know, having to run around and enforce standards on people isn't a lot of fun. People feel like hall monitors are the villain. Um, and the people who are on the receiving end of the enforcement is like, well, do you understand like how much pressure we're under to deliver? And then it becomes this dispositional, well, that's just because Carla thinks this. Well, no, that's because Tony never blah blah blahs. And you go in bad directions. So instead, what I recommend doing is automating as much of your compliance as possible. There's lots and lots of different tools out here that'll satisfy some of this stuff. Really opinionated linting and these sort of things are really simple examples of that. And build all that into your build deploy cycles. The biggest challenge an engineer should face in moving their code from their local box to production should be getting it off their box and into like the main branch. Everything else after that should get easier and easier. But the number of companies I've worked at where it took nothing to put code into the main branch, and then it was like the closer we got to production, the more serious we took testing. Yeah, that hurts. So make the biggest hurdle the one up front. The other thing I would suggest here again is kind of like establish a working group for this. Try and get as many people involved as possible in defining the standards so that these are our standards and everybody understands why we have them. Automate it as much as possible so it's not about Carla or Tony. It's just both know that the build failed because the dependency checker says we're using too old of a version of this. Yeah, and I think that it makes it people just view it as now it's more part of the rhythm of what we need to do when we're coding. Yeah, and what I wanted to share tonight. Like I said, there's a ton of other stuff. Um, there's a ton of other stuff we could have explored. There's a lot of stuff around culture, obviously diversity and inclusivity. These things deserve their own talks, which is part of the reason I didn't put them in here.